Hello, and thanks for joining me today. Are you someone who is responsible for the reliability of production services or somehow involved with production services? If that's the case, you've probably been in a situation where you're having a production outage or an incident where the service is unavailable or perhaps not performing well. And if users are unhappy, you may have leadership who's expecting you to resolve things really quickly. Well, if that's the case, then you've come to the right place. In this talk, we're going to talk about service outages, how you can learn from them, then how you can use those learnings to actually set your engineering priorities. We'll then move on to talking about specific engineering tasks you can use to target those reliability weaknesses that actually cause your users to be unhappy. My name is Yuri. I'm a site reliability engineer at Google Cloud. Unlike other SREs at Google who work on either internal Google production services or customer-facing services, my team is called Customer Reliability Engineering. And we work with Google Cloud customers to help them achieve the appropriate level of reliability for their services. If you like what you hear from me today, and if you're interested in hearing more, you can find more of my work on YouTube and on Medium, and I've shared a couple of links here. So with that said, let's get started. Everything I'm going to be talking about today is going to be within the context of SRE, or Site Reliability Engineering. So let's just do a quick refresher just to get us all on the same page. SRE started at Google because we realized that traditional operations wasn't going to be able to scale to meet our needs. So SRE is the result of turning operations into a software scalability problem. One of its high-level benefits is that it actually creates this alignment of incentives between different business units, those that might be responsible for velocity and those that might be responsible for reliability. And it actually allows us to maximize velocity of development while enforcing and ensuring that our services meet their reliability targets. Some of the fundamental concepts that I may refer to throughout this talk and that you should probably be familiar with would be things like error budgets and SLOs, or service level objectives. These two things are how we actually go about setting the reliability targets for our services. Blameless postmortems are absolutely critical to this, which is how we actually go about learning from incidents, and I'll talk about those in a little bit of detail later on. Now, of course, I'm skipping over a lot of detail here, right? If you're interested in learning more about any of these topics or to get some more background on them, feel free to go to google.com/SRE to learn more. So the reality is that we all work in a competitive landscape, right? If our users are unhappy, they have lots of options and they can take their business elsewhere. When we think about the products that we build and support, it's really easy to think about the features that we advertise, right? But this talk is really focused on what I consider to be the most important feature of any product, which is its reliability. Without that feature, and I say that in quotes, none of your other features will matter at all because there won't be any users left to actually use them. And when we talk about the reliability of our service, obviously we need to talk about the things that impact its reliability. Service disruptions, incidents, outages, right? Whatever terminology we use, right? In a large, complex, constantly changing system, it's really not a question of if there's going to be an outage or an incident. It's just a question of how often and what is the impact of each one of them. So let's have a look at how a particular service outage affects user happiness so that we can define some vocabulary around outages. In general, user happiness decreases while an outage is ongoing and then rises during periods of stability. So let's break this down into phases. This first phase is when our outage actually begins. Something breaks, perhaps we push some bad code, make a configuration change, right? Something like that. And our service is no longer working as our users want it to work. Notably, sometime later, the amount of time may be small, it may be large, but our alerting will hopefully let us know that this has happened, and our alert actually fires. The time from when the outage actually begins until our alert fires is what we refer to as the time to detect. This is how long it took us to detect that we're having an incident or an outage. At some point, once we receive the alert, we start working on the outage and we identify what can we do to mitigate it, to restore our service back to health. And we take those actions and we see our service start to recover. The time from when we knew about the outage, which is when our alert fired, until the time that we were able to mitigate it, is what's called, what we refer to as time to mitigate. And now our service is recovering, our users are getting happier, again, everything is good. but at some point we have another outage, right? Another outage begins. And this time from our last outage starting until this next one is starting is what we call the time between outages, right? So these are the three phases of an outage or an incident that we're going to talk about today. Now, importantly, we just had an outage. What did it just cost us, right? Now, there are obviously direct costs like lost revenue, right? Revenue that we couldn't make while the outage was happening. There may be some of our users who are so unhappy that they're never coming back. Some of them may be so angry with us that they'll tell their friends never to use us again, right? And those people will never become our clients, right? How much bad press did this generate, all right? How many angry tweets? So here's the real question. If we had a choice, how much would we pay to avoid this outage entirely? Well, when we think about doing retrospectives or postmortems about our outage, we actually turn this question to look at it from the other direction. We've already paid with the outage, right? How can we go about extracting value from that payment? What can we learn from this outage that'll make our future outages less costly? Or to put it another way, think of outages as unintentional investments. You have unintentionally chosen to invest a percentage of your revenue in discovering that you have a reliability weakness. What returns can you now extract from that investment? And this is what postmortems are for. The primary goals of a postmortems are to ensure that we fully document the incident, that we understand exactly what caused it, right, all the root causes of it, and that we identify, plan, and then actually execute the work to address those root causes or to improve the reliability of our service. So we need to figure out not just how to avoid the same failure and how to prevent it from happening again, but also how to address the entire class of failures represented by this particular outage. You should write a postmortem after any significant outage or near miss. So a near miss is something that doesn't actually end up affecting users, but it's because we got lucky, not because something went our way. And finally, it's good to recognize that writing a postmortem for an outage is not a punishment for somehow causing or impacting the outage, right? So often in engineering, we build things because we think they're a good idea, right? Postmortems are a great opportunity to identify things and tasks that we can prove are a good idea. The linchpin, the thing that holds all of this together, is a culture of blamelessness, right? So, for example, let's say that we have an on-call engineer, they get an alert for an outage, and they react by manually restart services that are running out of memory, servers that are running out of memory. We might think that's a good idea, but in this case, it actually causes a cascading failure because now the services that weren't restarted get more traffic, they've started to run out of memory, right? And now nothing can serve any traffic, and then this actually makes the outage more severe. Now, why did the engineer who was on call restart so many servers at once? Right? In the postmortem, we could state that, well, this was standard procedure. And in the past, we've done things like this and it's been successful. But in this case, very clearly, the standard practice has led to a bad decision being made. So we can identify that we have a need for tooling to automate this process to ensure that we always have, additional capacity available, right? And maybe in the postmortem, we can prove that actually cleaning up those memory leaks so we don't have those out of memory issues to begin with is actually worth the effort, even if it's a problem that we've known about it for some time and have never bothered to fix before. So in the culture of blamelessness, there's this basic assumption that people are acting in good faith. They're doing the best that they can with the knowledge and the tools that's available to them. And we want to identify causes for our incidents or our problems without implicating specific people. So one way by which we can actually put this into practice is by avoiding using names in postmortems. So we'll say the on-call engineer, the on-caller, not Yuri. If it was a bad commit, we could say it's commit number 1234, not Yuri's commit, right? You get the same information, but you're not putting the engineer who perhaps contributed to the outage in the kind of spotlight, right? Because what we're trying to do here is to fix systems, not people, right? Remember, one of the fundamental tenets of SRE is that we're approaching operations as an engineering problem. So when we have things that go wrong, we want to look for flaws in the system that allowed those things to go wrong. Now, it is important to understand that some of the fixes may involve people. So for example, Lack of incident response training is a people problem that needs to be solved by people training people, right? But we still think of it as a systemic issue. So the real point here is that if you actually want to learn everything you can from an incident, you need to be able to know what really happened. You need the truth, right? And you can't get the truth if people are scared to talk about it. We know that everyone makes mistakes, right? That's not the problem. The problem is that when our systems allow our mistakes to be damaging to our service. Once we start to accumulate a critical mass of postmortems, we can start to analyze them to identify patterns and to identify where we can actually focus our engineering effort. This list is, of course, not exhaustive, but there are some specific engineering tasks that we found that have a very strong impact on improving those three phases that we just covered a minute ago, right? Time to detect, time to mitigate, and time between incidents. If we want to improve our time to detect, if we want to shrink it, we really want to get better at defining failure and actually measuring. If we want to improve our time to mitigate, which is how long it takes from the time that we know about an incident until the time we can restore our service back to health, that's really all about preparing the responders themselves and the environment they're operating in. And finally, if we want to improve our time between failures or have essentially fewer failures, that is all going to come down to engineering discipline. So we're going to shift focus a bit here, right? This from here may become more or less relevant to your specific job role, right? We're going to dive deeper and discuss why each of the tasks that I just mentioned are actually important, and then how you might think about implementation for each one. If you're in a leadership or management role, you might want to think about the culture aspect that I just discussed, how to drive a blameless culture in your team or your organization. I have to emphasize, this is something that has to come from the top, right? If you're an engineer, it's kind of difficult to avoid blaming others when management is very intent on blaming you, right? But if you're in engineering, product management, or other roles where reliability is something that you deal with every day, let's get into the details. Having an outage and suddenly our budget burn is really fast, and if we don't actually fix it, if we ignore the issue, it'll eat up all of our remaining air budget. So the time to detect is from the start of the outage, right, from when this starts happening, to when a person that can actually work on fixing the outage or fixing the incident is alerted. Remember, if you're on call for a service, you can't begin to triage your problem until you know about it, right? So if you look at your postmortems and you see a significant amount of user impact in this first phase, this time to detect, this is where we need to tighten things up, right? So your SLIs drive your alerts, right? SLIs are service level indicators. Those are the metrics that we track that actually tell us about the health of our services, right? So it's really important that our SLIs are actually a good representation of user experience, right? One way by which we can make this happen is to measure as close to the user as possible. This means that if you can actually take your measurements from the client, right? If you're measuring a latency or availability SLI, then you want to measure latency or availability at the client because that's what matters to your users, right? You actually want to include like the flaking network links between the client and your service, right? If you know that your users need, for example, a sub 500 millisecond response time, right? If you measure this at the client, you may actually learn that your service can respond in at most, let's say 100 milliseconds to still deliver the end user experience that your users expect and need, right? This will mean that you will likely catch problems that are not necessarily your fault, but just because it's not your fault doesn't mean you can't do anything about it, right? Now, a lot of the time you will not be able to instrument your client for metrics, and that's okay. But you need to be aware that if that's the case, then your view of your user's experience does lack some precision, right? Another way in which you can improve and tune up your SLIs is to actually verify them against external sources, right? A good SLI is up when users are happy, and then down when your users are frustrated or unhappy, right? So, for example, if your SLI is showing that you're having an outage, but your users are not complaining, maybe you're measuring the wrong thing, right? So you want to try to understand user experience and to really understand what bothers them, what actually impacts their experience and their happiness, and then try to adjust your metrics, the metrics that you're using as SLIs, according with that, right? And just like you iterate on your SLIs, you also need to iterate on your SLOs, your service level objectives, right? Those are the things that set the targets for your SLIs, the reliability targets for your services, right? You need to have those targets align with user expectations, right? It's not usually obvious exactly what your users need. So as you learn more over time, you want to adjust your SLO targets, right? It is important to not set your SLOs to be too tight, right? Do your users really need 4 nines of availability, for example, or are they just as happy with 2? Every additional 9, so that means going from like 99% availability to 99.9% availability, or from there to 99.99% availability. We know that each of those 9s translates to about 10 times the cost due to engineering requirements, additional infrastructure, staffing, all those kinds of things, right? Running a service at those high levels of reliability, 4 or 5 nines, is really not cheap. So you want to make sure that your users actually need it before you commit the business to supporting it. And finally, your alerts need to be consistently and actually useful, right? You want alerts to fire only when users are actually being impacted. Now, this of course goes back to the quality of your SLIs and SLOs, right? But it is important to understand how good quality SLIs and SLOs directly translate into alerts that your engineers, your on-callers, can actually trust, right? You want folks to trust that when they get an alert, something bad is happening. Users are actually unhappy. What you don't want to train people to start ignoring alerts. Which means you need those alerts to be both sensitive and actionable, right? Which is kind of a tough trade-off to balance really well. But generally, this comes down to the period of time over which the alert evaluates the signal before it fires. If you're alerting too quickly, you may be paging at midnight for things that nobody cares about. If you alert too slowly, then you're losing that time to mitigate, right? And it can take some time and some tuning based on a history of outages to actually find that right balance. So we've covered shrinking time to detect. This was mostly about technical tasks, right? The next phase we want to talk about is shrinking time to mitigate or time to repair. This is mostly about the people. We're going to talk about policies, training, and stress management, believe it or not. Because even if you have really good SLIs and really good alerts with the right amount of sensitivity, what good is all that if the person who receives the alert immediately panics? My opinion is that this is actually the most important thing to focus on. You're always going to have outages, right? We know that. You can automate fast solutions to a lot of problems, but not all of them, right? We hire engineers because they're smart, they're creative, and ultimately they are the best resources that we actually have to address those problems that slip through the cracks. But they are also the slowest way to fix a problem, right? They are the last most capable line of defense. So it pays to actually invest in their success. I do want to make one quick reminder before we get into this section. An incident responder's first duty is to protect the user, right? So during the incident, right, we're thinking about mitigating the effects on users, not on finding and fixing all the contributing factors or even getting down to the root cause, right? So some things that are good to do as triage and mitigation, right? Temporary failovers, roll back to a known good state, emergency capacity provisioning or requesting more resources. Things that are not as effective, things that we know to be bad, debug the code, fix the code, check it in, build a binary, push it back out, right? Takes way too long, and we know that it's actually really risky, right? How do you know that the fix you just put into the code doesn't cause a different problem or even fixes the issue to begin with, right? That's the kind of stuff we want to do later while we're not actively burning error budget. So that's a key point that I want to make, this distinction between triage and mitigate, which is what we think about during an outage, and root cause analysis and fixing the problem, which is what we do when the outage has been mitigated. So this particular section is all about that time to repair, with the assumption that we're focusing on mitigation. So what can we do to improve time to repair or time to mitigate? Well, the first thing we need to do is to improve our responders' capabilities. We need to actually train them, right? So we need to have emergency procedures that are not just defined, but actually well tested. so that everyone who is involved can be calm and productive during an outage, right? Specifically, we need procedures that provide both enough structure and protocol so that we have an organized response, but also we need them to be open and flexible so that responders can actually do ad hoc exploration if that is what this particular situation calls for, right? And our training shouldn't be limited to just the people on call, right? We want to include everyone who could potentially participate in incident response, right? So that's going to include folks in development or product engineering, product managers, even executives. And importantly, we can't just train people once and then assume that they will retain this forever, right? If you're not using incident response training, it can get rusty very quickly. Here at Google, as an example, many of our service teams hold weekly failure drills, right? These could be practical, where we actually modify the services and start introducing additional error rates or latency or something like that, right? Depending on the test, they could be real user-facing systems or just replicas or something like that. We also run theoretical drills, where we might just talk through how to handle a particular situation or a particular kind of incident. These drills don't have to be very complex. You can just start with a very simple example. Users are complaining they can't log into the service. What do you do, right? In either case, whether you're doing practical failure drills or just theoretical failure drills, the team gets experience with critical thinking, communication, and knowing when to escalate, right? The second thing here is that you want to actually write what we call alert runbooks or playbooks, right? This is basically the first thing that an uncaller sees when an alert is fired, right? You really only need to write one for every alert that can fire. And in them, you want to write down things like response procedures, links to dashboards that show more information about the state of the system if that particular alert fires. Maybe specific search queries to find the right debug logs. Generally, anything that someone who's handling this alert might want to know and is probably not going to remember in the stress of the moment. Now, I'm not saying that you need to know every possible cause and fix before you even make an alert, right? That's obviously impossible. But the runbook should give a responder a clue for how to start the investigation, and then if needed, where to go for help. Now, something that does happen a lot is, if someone writes a runbook, right, but then no one else can understand it, right? When you write one of these things, even if you think you're just writing it for yourself, you want to keep it as simple as possible. Think about writing it for a version of yourself that just got back from vacation and has completely forgotten how to do your job, right? Trust me, you will thank yourself later. And now this is actually a good opportunity to do a failure drill, right? Send an alert to someone and see if they can follow the runbook you've just written. Is there anything they had to do that wasn't in the runbook? Well, this is your opportunity to add it, right? You want to be as thorough as possible. It is very easy to forget even the things that you think are simple and basic in the stress or heat of an outage. Next, let's focus on the on-caller's responder, the on-callers or the responders themselves, right? We know that pager fatigue is a real thing, right? Being on call is a hard job. And if you want to keep your on-callers, you do want to make their happiness a priority, right? Over time, we found that incident responders can handle about 2 pages per shift or 2 incidents per shift before they start to feel overloaded. This, of course, will vary between teams and companies, but this is a good starting point to aim for. We do want to automate some of our routine operational tasks, as much as possible, right? Within site reliability engineering or SRE, we call this eliminating toil. One classic example of this is release management, right? How much of the release process are we able to automate so we don't actually have to babysit? And if the load is just too high for the operational team, we actually want to be able to shed some of the load, right? We want to ask the developer team to handle, for example, excess pages, or maybe we need to go so far as to actually loosen our SLO until our service is stable enough, right? And finally, dashboards and logging, right? This is the final thing, right? We want to measure everything, right? This is an SRE motto. We're going to record every response code, every lock contention event, every queue length. And then we want to visualize these metrics on task-specific dashboards so that on-callers have the data that you need to make tactical decisions. Now, I do want to acknowledge that all of this observability or telemetry data is going to cost a good bit of storage, perhaps. So it is good to set retention limits for metrics so that we keep only the ones that we actually need for long-term decisions. All right, you've mitigated an outage. Great job. Your users are starting to kind of rebuild confidence in the service. And generally, you might think that we want this phase to last as long as possible because this is when users are happy. But we know that the only way we can avoid outages completely is to stop all changes to our service. And while that might be a good idea, if, for example, your business depends on one weekend a year to make 80% of its revenue, for most of us, that's not really an option. So let me revise what I said. We don't necessarily want this phase to last as long as possible, right? Because if you go too long without an outage, the next outage will be that much worse. On-callers get out of practice, runbooks will get out of date. And in general, my strong recommendation is to think about focusing on shrinking those first two phases, time to detect and time to repair, right? With that said, there are still things you can do if this is something you're interested in. They're going to fall into four major areas. The first major area you can focus on is all about engineering practices or development practices. So this is where we want to think about really emphasizing a culture of quality, making sure that we have test coverages and things like that we have good discipline around test reviews, that we actually put explicit requirements in place for how our tests cover our code. The second major area we can focus on is all about automation. How do we build our code? And then how do we deliver those built artifacts to our production systems? So this is where we want to focus on things like automated testing, gradual or canary rollouts, and very importantly, automated capabilities around rolling our code back if we do detect that something we pushed is actually causing our users to have a bad experience. The third major area we want to focus on is all about the architecture of our services. So we want to do things like avoid single points of failure, right? We want to make sure that everything is redundant, that everything can scale. That if we do have any issues with service, if things degrade, we want them to degrade gracefully. So for example, in that example that I brought up when I was talking about postmortems, right? Our service wasn't able to degrade gracefully. When we restarted servers, it actually caused additional servers to crash. We want to avoid that, right? Any server in our group that can't handle the traffic it's getting should be doing its own load shedding and throttling, not just dumping it into other services to handle, as an example. And then the fourth major area we want to focus on is all about chaos engineering or resilience engineering. Generally, this is going to be our opportunity to find issues in our systems before those issues find us. And we want to automate our disaster recovery capabilities as much as possible as well. But the main takeaway from this entire session, everything I've talked about, it all comes down to one thing. The information you need to improve the reliability of your services, to shrink the time to detect incidents and the time it takes you to mitigate incidents is in your postmortems. You've already made those investments. Now it's all about getting the return on those investments, and your postmortems are going to tell you just how to do that. Thank you so much. Thanks for watching.